mathematics and music, the most sharply contrasted fields of scientific activities, ties together all the activities of our mind. What is music? Music is the art of arranging tones in an orderly sequence so as to produce a unified and continuous composition. In regards to mathematics, it is the ratios of sound waves. In order to widen our knowledge of music and mathematics, we are going to discuss the journal entitled Math and Music Theory by Adam Townsend, which he did in February 2011. This journal contains the compiled notes Townsend made in the slides of his presentation in the 45-minute talk he performed at the University College London undergraduate math colloquium. This, therefore, is more detailed than what he did in the talk. According to Townsend, this journal wouldn't be made possible without the help of the excellent work of Thomas M. Fiore of the University of Michigan. A musical instrument that can show the correlation of music in mathematics is the piano. As we know, there are sound waves coming from all around us, even though the average human can only hear from 20 Hz to 20,000 Hz. Therefore, 20 Hz would have a much lower frequency or sound than 20,000 Hz. The frequencies of the average piano range is from 27 Hz to 4,186 Hz, with middle C being 261.63 Hz, middle C with a frequency of 262 Hz or 262 repeating tones per second, creates a pattern that looks like this. Mathematically, this note C is referred to as sine 542 pi x. The note A above the middle C produces a wave like this, while C sharp and E produce waves like these. Second, wave amplitudes can correspond to the unit circle when it happens. And just like how the unit circle corresponds to various frequencies, sound can also respond to various shapes, which is called sematics. The higher the sine function, the higher the frequency, and therefore, the more intricate the pattern or Buckminster Fuller even said.
A sound is some kind of vibrations which the ear is sensitive to. It is a to and fro motion. A vibration becomes a sound only after it is interpreted that way by the human sight, which is the center of an individual's emotions. The larger the to and fro motion, the larger the sound. This is known as the amplitude. The rate of which vibrations are repeated is the frequencies, and the frequency determines the pitch of the note. Every note can be modeled as a sine wave. If the note has a larger amplitude, the note would be louder, and if it was quieter, the amplitude would be smaller. As shown here, as one note of the same pitch at 3 different volumes. Similarly, a sine wave would be a higher pitch with a higher frequency and vice versa for lower frequency. Here it models 3 different notes but all at the same volume. We now have all the information to construct a sine wave for a note. We can take an ordinary sine wave and multiply it by the amplitude A. The period in the wave is given by frequency f multiplied by 2 pi t. Taking this wave and the fact that frequency equals 1 over capital T, we have that y is equal to a sine 2 pi t over t. Let's check this if we take the point t equals pi over t and plug it into the formula. We see that y is equal to a, which is correct based on our graph. Putting all of this together, y is equal to a sine of f times 2 pi t. Sine and cosine waves are incredibly important for understanding all sorts of waves. Musical notes can be thought of in terms of sine curves, where we have the basic formula y is equal to sine of bt, where t is measured in seconds. B is then connected to the period of the function by the formula period is equal to 2 pi over b. When modeling sound waves, we normally work in hertz, where hertz just means full cycles or periods per second. This is called the frequency. Sine waves with different hertz values will each have a distinct sound, so we can cycle through scales in music through sine waves of different periods. For example, the sine wave for 20 Hz is 20 Hz means 20 periods per seconds or 1 period per 1/20 seconds. So we can find the equivalent sine wave by using period is equal to 2 pi over b or 1/20 is equal to 2 pi over b. B is equal to 40 pi. So 20 Hz is modeled by y is equal to sine of 40 pi t.